So in this problem, what's going on is basically you've taken a small patch of membrane near the axon hillock, which is going to contain voltage gated sodium channels. In this case, they've done 10 different patches of membrane, A, B, C, D, E, F, G, H, I, and J. And what they've done to those membranes is they've gone to the voltage membrane potential, and they've changed it from minus 80 to minus 40. And when they did that, these are the currents that they saw in response to those. Again, they know that there are voltage gated sodium channels there. They can see the currents in response to the voltage changes, again, because current and voltage are related to each other. Okay, and these are 10 individual patches of membrane that have these channels. Okay, it's not the same patch of membrane, it's 10 different patches of membrane. And then your job is to answer these questions about the properties of those channels based on what you see in the recording, based on what you see in the current that's there. So what does the negative downward current tell you about the channel? Why do the channels have such short durations? Which of the recordings might have two channels in the membrane? What could you do to get another sodium current in the recordings? And that's purely based on no other changes that are made. You only get one current in each of these. How could we potentially get two? What would we have to change in order to get a second current in there? Then how could you get the current to flow the opposite direction without changing the ion concentrations? So you can't go and mess with sodium concentrations or potassium or anything else. And then if this had been a voltage gated potassium channel instead of a voltage gated sodium channel, what would have been three differences in the currents? Okay, name three things that might have been different between the two. So hopefully that helps with this question. I know this one can be a little bit tricky. Give it your best shot, and we'll see how it goes.